Welcome to this explainer. Today, we're diving straight into an incredible instructional guide built specifically for tech educators. We're looking at a roadmap called LogicLadder, and it details exactly how to teach absolute beginners the ropes of setting up a C++ programming environment. It's a fantastic approach, so let's get right into it.
Right out of the gate, the guide suggests this absolutely brilliant psychological trick. You start at the destination. By showing your students the exact outcome they're going to achieve, a terminal successfully printing "Hello World," you secure an immediate tangible win for them. This whole strategy is specifically designed to keep learners motivated for those much tougher coding challenges that are definitely coming their way later on.
Here's the exact map of our climb. We'll cover 1. The language of performance. 2. Installing your digital translator. 3. Setting up VS Code. 4. Your first C++ project. And finally, 5. Embracing the growth mindset. This sequence is precisely how the curriculum takes a student from a blank screen to a fully functioning professional development environment.
Let's kick things off with Section 1, the language of performance, and exactly why C++ matters in 2026.
Now, the curriculum makes a really compelling point right off the bat. We all know Python is a fantastic entry point, right? It's easy, it's accessible, and highly abstracted. But C++, that is the true language of performance. The source notes that if your ultimate goal is to build those high-performance agentic AI systems that'll be dominating the software landscape in 2026, understanding hardware-level memory management through C++ isn't just nice to have, it's absolutely mandatory. It literally forces a student to learn what's actually happening under the hood of their machine.
Moving on to Section 2, installing your digital translator, bridging the gap between human and machine.
You know how easily students get bogged down by complex tooling? Well, to demystify all that, the guide highly recommends ditching the heavy jargon. Instead, just frame the compiler as a simple digital translator. That's really all it is. It takes our human-readable instructions and converts them into raw binary, the ones and zeros, that the computer's processor actually understands.
To keep things manageable, the installation is broken down into 3 logical steps. Download an industry-standard compiler like MinGW or Clang, configure it, and verify it. And there's a fantastic production tip for educators here. It advises using screen recording tools like Turing Shot to zoom directly in on specific download buttons and those notoriously tricky environment variable setups. Doing this ensures your viewers literally never get lost in the weeds.
For that final verification step, the student simply types a quick command into the terminal, G++-version. Once that version number pops up, it proves to the learner that their digital translator is securely installed, properly linked in the system paths, and completely ready to go. It's a great little confidence boost.
All right, on to Section 3, setting up VS Code, your professional workbench. Setting up Visual Studio Code as the primary IDE comes with some fascinating behind-the-scenes insights for content creators. For example, it actively advises bumping up the font size. Why? Because a full third of learners are watching on mobile devices. It also recommends applying a high-contrast theme and completely disabling the blinking cursor. This gives you super clean video cuts and removes a really subtle visual distraction for the student. It's those little details that make a huge difference. This brings us to Section 4, your first C++ project. It's time to write Hello World. When we hit the live coding segment, the curriculum starts by including the standard input-output stream. The educator's goal right here is to carefully explain that this line is really just borrowing some pre-written code. It's the exact thing that gives our program the magical ability to print text out to the screen. Next up, we add our main function and the actual print command. But here's the kicker. The guide specifically instructs the teacher to intentionally leave out a critical piece of syntax at the very end of that line. Leaving it out sets up this absolutely brilliant teaching moment. That missing element? It's a semicolon. And you explain to your students that in C++, a semicolon acts exactly like a period at the end of a sentence. It clearly signals to the compiler that the instruction is totally finished, preventing the computer from just reading on to the next line and getting completely confused.
And that leads us perfectly into Section 5, embracing the growth mindset. Let's talk about what happens when things break.
The curriculum pivots here to a really crucial pedagogical question. What exactly should a student do when they intentionally delete that semicolon, or maybe misspell a command, and the entire program just completely breaks?
Instead of glossing over the mistake, the guide insists you teach students how to actually read the error message. If you look at the terminal output, it literally tells you the exact expected character, the semicolon, and precisely where it expected to find it. It hands the developing programmer the exact solution to their own problem.
This ties in so perfectly with an insight from a 2025 Snapify guide that's heavily referenced throughout the source material. A growth mindset means learning to embrace these red error messages as a developer's true superpower, rather than seeing them as a sign of failure. Getting comfortable with errors is what builds the resilient mindset required for real software engineering.
So, by independently solving that error, compiling the code, and finally executing it to reveal the output, boom. The curriculum ensures the student secures that vital first tangible win. They transition seamlessly from high-level theory to actually building and running a real piece of C++ software.
It's just fascinating to see how deliberately a technical curriculum is constructed, isn't it? From building in those early psychological wins, right down to optimizing screen recordings for mobile viewers. Now that this professional environment is set up and that first program is running, your students are fully equipped for the ladder ahead. But as coding education continues to rapidly evolve, it leaves us with a massive question to ponder. How will these fundamental teaching methods have to adapt as AI begins writing the code right alongside us?